You know what hurts? Pain. But why does pain have to hurt so much? And could we maybe dial it back a bit if the pain gets too intense? Thanks to a recent study from Stanford University, we may just be able to control how we experience pain. As much as it hurts, pain is useful in most cases. It lets us know that what's happening is bad for us, or when something is seriously wrong. Without it, we would easily injure ourselves or not realize our bodies aren't functioning as they should. In fact, there is a rare condition called congenital insensitivity to pain with anhidrosis, or CIPA, and people suffering from it can break bones without even knowing it or overheat easily, which is especially dangerous when they're children. So pain is a good thing, or at least the ability to feel it is. But there are those on the other extreme of the spectrum who experience chronic pain. For them, it mostly serves no purpose other than discomfort and agony. Drugs like opioids can dull the pain, but they can be extremely addictive and impact other parts of the brain. So identifying exactly which neurons control the discomfort that comes with pain can lead to new drugs that allow people to still know they're hurting, but without the actual hurt. That's where a 2019 study published in the journal Science by researchers at Stanford University comes in. The researchers probed mouse brains for where pain was felt. And when I say probed, I mean that literally. They attached miniature microscopes to the mice's heads and observed their brains in real time while the mouse was just walking around doing mouse stuff. The scientists' target was the amygdala, which in humans is a small almond-shaped area associated with processing emotions. But it's really dark inside a mouse's brain. So, to see what was going on, researchers introduced a fluorescent protein that lit up whenever neurons fired. With microscopes and glow-teens in place, researchers started poking and prodding the mice to see what areas lit up when they were in discomfort. They found about 150 neurons in a region called the basolateral amygdala that sparked up when the mouse was in pain and glowed more brightly when the pain was more intense. But the scientists weren't looking for neurons that signaled pain, but the ones that signaled it was unpleasant. To find out if the neurons they'd spotted were the ones they were looking for, the researchers created chemical switches that allowed them to turn the neurons on and off. When the researchers switched the neurons off, the mice could still sense pain and would show it by displaying their usual reflex to withdraw from painful stimuli. But they didn't show signs the pain was unpleasant, like by avoiding the stimuli or by licking their paws. Essentially, they could still feel pain, they just didn't mind it so much. When the researchers switched off the same neurons in mice with chronic pain, they found the mice didn't mind the light touches that used to harm them anymore. If neurons that work the same way can be found in humans, and if these neurons have unique receptors, then it might be possible to develop drugs that target them and turn down their activity. That would be huge news for sufferers of chronic pain, or even those in intense pain who might otherwise be prescribed drugs that are addictive and imprecise. It's probably still a ways off, so in the meantime, do your best not to hurt yourself. So, would you let scientists attach a microscope to your brain if it meant making a major breakthrough? Let us know in the comments. And for more on the science of your brain, check out this video. Thanks for watching, and I'll see you next time on Seeker.